When you're writing programs that have conditional statements that can go in one of many different directions, not just one or the other, and you start to see your code having nested if-then-else statements where you start having levels of indentation that are deeper and deeper and deeper. There's a little trick in an extra piece of syntax we should talk about called the elif statement that will allow us to clean up our code without giving up any capabilities. Right? So this is going to be what we call syntactical sugar. It doesn't give us any new capabilities, but it just makes our code a little bit sweeter. Right? So with nested if-then-elses, we can imagine something like this, where we have an if statement where if response is equal to 0, we print very doubtful. Else, if response is equal to 1, we print ask again later. Else, we print it is certain. And notice that we are nesting that if-then-else one level of indentation deeper than we were in the outermost level, right? So we've got our this if is paired with this else, and then within this else's body, we've got all of this indented to indicate that this is all part of the else block. So if response is 0, then we would never test if response is 1, right? Based on how this conditional is written. And so it's very common that you'll see scenarios where you want to go, and in this case, this is 1 in 3 directions. But if in some cases you want to go 1 in 5 or 10 different directions, or if you were writing a true magic 8-ball, you might want to go in 16 different directions. This would, like, if you needed to keep indenting each else branch, it would be quite tedious. Right? So we're going to look at a special new piece of syntax that'll allow us to clean up our code. That's called the elif. That's short for else if, as we'll see here. So there's this else if construct where when we see this pattern where we have an else branch, and inside that else we have another if then else, what we're going to do is we're going to delete everything from the SE, right? So everything from here all the way to the start of if. So we're going to bring L and if together, and we're going to bring if up to the next line, as you'll see. So we change that line to be elif, and notice then we have an indentation issue. The next step is going to be we need to clean this up, because notice that with this indentation, this is 1 tab, 2 tabs in, this is 1 tab in, but really we want it to be lined up with the other statements. And this is also 1, 2 tabs in. So we really want to bring those back out. We want to unindent them by 1 level. And we'll look at how we can do that in just a moment. So the next thing we do is exactly that, where we take those 3 lines and we bring them back so that the if, elif, and else are all aligned vertically and they're all connected to one another. And so notice we're saying if response is 0, print very doubtful. Else if response is equal to 1, print ask again later. Else, print it is certain. And so only one of these 3 branches is going to be evaluated when this code runs. Right? This is only a stylistic change. As I mentioned, it's syntactical sugar. But our code is simplified, it's easier to reason about, it's easier to read, and this is much more conventional of someone who has written some programming, or has written some programs and is comfortable programming. You would expect them to write nested if then else conditionals like this, rather than like we've been writing so far. But because this really doesn't give us any new capabilities, we've held off on, and this is really just a detail. All right, so let's try this out, and I'm going to open up an example from past where it's this 8-ball example, right? And if you want to find an example in your code where you've got this pattern of if then else, you can follow along and with this transformation, right? It doesn't matter where in your code this is. This works anywhere you've got an else statement, and then right within that else, another if then else statement, right? So again, the first step was to delete all of the text that I have selected, right? So notice we're going to go from else colon and then a new line and an indentation to just elif. And so I'm just going to delete that. And we've got elif n is equal to 1. And then for the remainder of this, and this might be even more, right? If you had 3 or 4 or 5 levels of indentation where you had more and more nesting, you would want to select all of that. And to bring all of that text back, most programming editors, including VS Code, have this ability where if you hold down your shift key and press tab, it will unindent all of your selected text by 1 level, right? So I could press that again and it would go back by 1 more. If you press tab, it will tab all of what you have selected in by 1, and shift tab will bring it back. This is helpful for quickly formatting your code and bringing it into alignment. So now we have this pattern. And notice that this reads a little bit more easily. It becomes more obvious that this is these are related branches, and this is only going to go in one of three directions, right? In this case, we would never hit more than one return statement. And this would be true even if they were print statements like we're seeing in this example. So to try and visualize the difference between three unrelated independent if statements and an if, elif, else statement, I want you to consider the following code. And this is sort of pseudocode. We don't have specific conditions here for A, B, and C. But imagine that A, B, and C are three different Boolean tests we could perform. Well, notice that if we have if A, print X, if B, print Y, and if C, print Z, these are three unrelated conditionals. Right? Each of these three will be tested. And if A, B, and C were all true, then we would expect X, Y, and Z to all print. So with this code listing, each of those conditionals could evaluate to true, and we could see each of those print statements evaluated. In a flowchart, as we're seeing here on the right-hand side of the screen, notice that there's a path through each of X, Y, and Z, right? So A can either go to X or to B, which is another decision, another if. And once again, when we reach that if, we can once again, there's a path through all of X, Y, and Z. Now this is contrasted with what we're just looking at in our if, elif example, where notice when we connect these three in a conditional, where we have if A, elif B, elif C, and we could have more elifs as well. What we're saying here is this code is going to go in one of these three conditional directions, right? If A is true, we're going to print X, and then we're going to skip over everything else, as if those elifs were nested in the else branch of if A, else, if B, else, if C, right? So you'll notice that in our flowchart here, if A is true, we go to X, and then we would skip over everything else and then be done. Similarly, if A was false, we would test if B is true. And if B was true, we would go to Y, print out Y, and then go to the end. So in this case, there's only one of X, Y, or Z that would print. And since there's no else condition here, there's no guarantee that any of these three would. If one of A, B, or C was true, we would be guaranteed that only one of these three print statements would be evaluated. So understanding the difference between three unconnected, unrelated if statements and three branches of an if, elif, 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 else, or however many you have, is fundamental to understanding there is a big difference in how those two statements are evaluated and how to think about the logic and the control flow of those programs. So that is all we've got for introducing elif. We'll have a challenge question about this, and hopefully you've got a sense of how to write simpler conditional code that has many branches.